Hey, hi everyone. Welcome to H&M Technologies online training. Now in this video, we're going to explore the remaining part of operators, so which is a part 2. In the previous video, we learned arithmetic and assignment operators, like and comparison operators, right? Now in this video, we're going to explain about logical membership and identity operator, and also bitwise operators. Now think about your college exam eligibility. It's not just about your marks, you need marks and attendance and fees payment, right? Altogether, one fails, you're out. That's exactly what's doing today operators do. They help Python to combine conditions and make smart decisions like real situations. And today we're going to cover logical, membership, identity, bitwise operators. And let me open VS Code. Yeah, this is a VS Code. And here, there is the remaining operators we're going to cover. Logical operators which are and, are, not, and identity operators is not, in, not in, and bitwise operators, and these are we're going to explore. Now let me start with a logical operator and are not. So logical operators combine multiple true false values into one final relations. You see, yeah, you can use this in a real life, say, everyday simple life. You just don't know Python had do them. Okay, I'll go with the logical operator for which is and right. Now I'll take my example from real world like ATM machine. ATM withdrawal is yeah withdrawal machine. So, ATM withdrawal has need to buy a card and a pin, and we have not just a pin as a valid pen, right? And I have enough cash right in my balance. Now just the so these three conditions must be true. Okay, has a card that has card, I use and has a valid pin, I use and has a enough cash. So then I can print can withdraw. So here I'll tell true. What if I have this is a one? What if I have anyone false? Right? Yeah, you can see false. Card. I don't have any card. Or if I have a card and I don't have enough balance. See what it will do. Yeah. See. And is all like always searching for false. If everything is right, it will to you right. If any one is false, it will give you a false only. So this is our and statement. And now let me give you another example. Right. Exam hall. Not going to all. I'll tell you another example about and operator. Yes. And It's eligibility. Yeah, this is has ticket, right? True, as eligible. And instead of this, I'm going to take variables like a different way. I'd like to see, I can take in real world marks. I'm having 75 and attendance and 80% of attendance. Now I'm going to fees or fees paid or not. So yeah, that's my paid. Now 10 eligible. Yeah, you can see. Take always. I'm going to print a eligible statement in formal string, not just a true. I formal string. Yeah, yeah, you can see here. Marks 75, attendance 80, and fees paid true. Right. So eligibility, I check eligibility marks greater than 40 and attendance greater than 75 and the fees paid. Fees paid must be true. If it is false, it will give you eligibility false. So this way we use AND statement everywhere. Now, even if it is 99%, 99 conditions are true and just one is false and returns are false, all B must be false. Okay. Now I'm going to take a power. Right. Now in this situation, I'll take I'd like to go with to get in into a hospital. You can maybe a patient or a doctor or a visit. Just one is enough. I'll go. So and sorry, if I have an emergency situation, yeah, see, is parent. I take false and is a guardian. False is emergency contact. True. And I'm going to use a variable called should notify. Right. Yeah, should notify. If I use a should notify variable, either user is parent or is a guardian or is emergency contact. I'll notify. When notifying is a true. So here Any one is enough. Is not a parent. Is not a guardian. Two statements are false. We have only one emergency contact. It is enough to notify, right? So, or is always looking for at least one true. Okay. If it is one is fail, and I look for another true. That also true fail, and it look for another true, like that. Or is like that. Even it this or that, like that. Okay. And I'll go to not. I'll show you what happens if not. Yeah, not, not in real life. If it's it not booked, show it as available. Simple flip. I'll use is seat booked files and is available. So is it not booked? And print is available. I use not. Not is like a seat is booked. No, seat not booked. Is available. It's took not seat is booked. No, the printing is like a is available. So not seat booked means here I'm assigning is available to not false. No, if it is seat not booked, it is available, right? Like that. And what if it is true? I'll show you. Is yeah, see, you can see false. It's like a flip, right? And this is not operated. And I'll clearly give you a state sheet for both. Like here I'll give. And yeah, true and a true. I'll give it. And true and false, I will give false. False and true, I give false. False and false, false. Because even in a true understatement, both will be true. Okay, here will both will be true. Here, uh, both not are true, and this only one is true. These are both false and real false. Because here you can see and is always looking for false. Here, first in first situation, we have you can see here. Here, one is true, and it's checking for is there any false. Then here it is false. Then it will return a false. Okay, but here is you can see first one is a false, and it will don't go to the next one. It simply print the first false. Like that. It's always look for false. If it is one is false, it simply goes to the false without checking another one. Now coming to or, it is always look for true. First one is true, and again it true, and it don't go to next one because the first one is true. Or is once always true. So first one is true, then it prints true. And here also, first one is true, it fills true. And here, first one is a false, and it again checking to is there any true, and the second one is true. So it prints the second true. Here you can have both are false, so it can't do anything. So it prints a false and not. So not true means that false, right? And if Not false means the true. So this is how this and or not works, right? Yeah. And we'll go to next operator, which is our membership operators. Membership only, identity. Yeah, okay. We use yeah, identity operator. Yeah, identity operators. So identity operators like is and is not. Only two operators we have. Like is comma is not. I'll go into below. This is the most misunderstood concept for a beginners. For example, think of this. This is equal to like or the values equal, and if is like or the objects the exact copy, exact same object. Objects in memory, right? Sure. No. Real life analogy. Yeah, I can see. If I go this, x equal to 5, y equal to 5. Print x is y, it prints true. Yes, no, this is both are same. So that's why it prints a true. Checking that one is a true one. And here you can see x plus x equal to 5 and y equal to 6. But x is not y. This is so right. X is not a y. Both are not same. So this feels true like this. And coming to the next operator, we'll go with some more example. Like here, X I'm having a list of 1, 2, 3, right? And Y have 1, 2, 3. So both are same. It seems both are same. Identically, it seems both are same. But X is Y, false, but not same. And because both memory locations are different, and it is not Y. There you can see X equal to list of 1, 2, 3, and Y equal to 1, 2, 3. So I'm printing X is not Y. That's exactly true. But this is both are seems identical, but not true here. So because two different lists here and two different variables. This is a different variable with a different memory location. This is a different variable with different locations, right? Yeah. Now, We'll go to membership operators. Yeah, the sixth one is a membership operator. Not in and not in. If a list of any list in my list, I have this one, two, three, four, five. I'm printing three in list. I'm printing to check not in list. Like see list 1, 2, 3, 4, 5. I have and three is in a list. So then it will give a true. It's not in my list. It give true. This is what happens. Six is not in a list, so that's why it's give true. If I change this, it gives false because five is in a list. It's not in a list. It's give false. Yeah, but six is not in list, so that's why give true. If I go to strings, my string is a hello word. I'm printing L in my string. It gives it true because L is in my string. I say HELLO, and like that. Z is not in my string because Z is not there in my strings. So that's why I'll tell O is not in my strings. So you can see output is false because O is present in my string. So that's why it's a given false. This is how we use in strings and with the help of dictionaries. We just membership operators we use the whether our values are in collections in a list or a tuple set dictionary. The value is a present or not. So this is the way we use membership operators. And tuple, I use this using. Yeah, you can see. In tuple also, this is the way we use. And even it is a dictionary or a set, I will take this example. Yeah, this is my set. Three is my set. True. It's not in my set. It gives that true. And whatever is dictionary, yeah, I can see where it is dictionary. I'm checking. So dictionary works differently because a dictionary have a value and key case. So that's why I'm going to check. A is a dictionary. D is not a dictionary. Both will give true because we're checking keys. But what if I want to check value? So value, I can check which value I'm going to check. Key dot of value. Value 2 is a present or not. I'm going to check. Print 1 is in dictionary. So 1 is there in dictionary, but it gives false. Why? Here it is a cool thing. Not in a dictionary. Yeah, it's not in a dictionary. It again gives a true because 1 is present in a dictionary. 1 it takes as a key. So if I give 1 with the help of a string, it is going to be a true. Instead of D, if I give 1 as a string, that I'm assigning to 4. Now you can see output changed here. Before, one is not in my dictionary, but now it is going to give true because the one is present here, right? But what if my dictionary I'm going to check with a value? In this case, I have to check with the help of a dot value. Let's see. I'm going to print. Yeah, you can see in a value because tuple. Sorry, here I gave comma. Let's make it tuple. Yeah. See one mistake. I just gave a comma here, and Python runs takes as a tuple. But I remove and I can see print one in a dictionary dot values. I'm giving a dot value. It's a whether it is value or not. Yes, it giving a value is a present. Just I'm going to remove this. Yeah, you can see if I click on yeah second check true and one and if I going to check a value I'll use the values. This by default checks are keys, right? Yeah, this is the way we use membership operators in a list, tuples, and sets, and also dictionaries. Cover identity operators, and we're going to cover bitwise operator, right? The last one, bitwise operator. Yes, yeah, I can see. So these are the bitwise operators, bitwise and bitwise or bitwise X, bitwise not, left shift, right shift. We'll see how to use these bitwise operators. We have six bitwise operators, right? And now we going to see how to use. Work directly on a binary representations, zeros and ones. So you won't use them daily as a beginner, but you will see them in a technical interview, system level programming. First, quick binary recap. I'll go with the binary number. I'll tell you. Uh, Binaries. Okay. Decimal 5. This is like the binary representation 0, 1. Yeah, you can see. So in our basic signals and systems or in a DLDC subjects, we have this binary representation 5, 0, 1 because we use represents a binary in this form, right? Binary. And what if I use this example? I go with the A equal to 5 and B 3. I'm going to take a bitwise operator, bitwise and mm, yeah, bitwise. If I print this, the answer is 1. Okay, now I'll show you how it is explains. 0, 1, 0, 1. Yeah, so this is our binary representation. 0, 1, 0, 1 or 5. Yeah, but okay, so for this, the binary representation is 0, 0, 1, 1. This is the here you can see between one operations 1 and use bitwise or I print 7 like this way, and if I use XOR, so this bitwise XOR, bitwise not also like this. That wait, yeah, and bitwise not is done. I use if I go with the bitwise not completely, then left shift or right shift. This is a bitwise left shift. Uh, yeah, there is a left shift and right shift. So I'll tell you clearly this is what exactly happens if in a bitwise right shift. What happens is b is greater than 2, right? I'll a, yeah, here we have a b 5 and 3, right? Yeah, how it is happening. This is the right shift. 2, 4, 2, sorry, 1, 2, 8, 16. These are the numbers we use in a binary representation. So like this is the 2, 1, 2, 4, 8. So 1 means that is S. 1 means H is S because I'll give you an example. 1. 8, 4, 2, 1. This is where we represent binary. And if it is a 1, here again is 4. 8, 4, 2, 1. 8, 1 is 1, 4 is 1, so means S. 4 plus 1 is 5. And here you can see 8, 4, 2, 1. So 1 is S, 2 is S. So that means 2 plus 1 means 3. This is the 3. Like that we use in a bitwise operators. So this is what happens. So we'll see in detail about this bitwise operators, how to use in a real world and programming in later classes, right? Now let me recap everything. What we discussed: arithmetic operators, which are plus, minus, like addition, subtraction, multiplication, division, floor division, modulus, and exponential, right? And assignment operators, equal, plus equal, addition, equal, like, this is the assigning operators. Comparison, true or false, logical, uh, and or not. And membership order operators we use it to check whether a value is present in collections like list, tuple, set, and identity operators. So whether is identical or not. So checking same object or not. Is not in, and bitwise operators. Permission and fast math that we will see. And coming to our next video, so conditional statements where we combine everything we learn to make Python take a real decisions. Okay, thank you.